In this video, we're going to discuss compound interest. We're going to be using these formulas here to calculate compound interest. So interest is just money that is deposited in your account, like if you have a bank account or something like that. The bank's basically paying you to borrow your money, essentially. And so there's different types of interest. Simple interest is just going to look different than this. Compound interest, as you can see here, is an exponential equation. So t is our variable once we plug all the other information in. And we've seen that exponential functions increase really fast. And so that's going to be the case with the compound interest as opposed to simple interest. So for these formulas, t is the time in years since the deposit was made. These formulas only work for like just depositing some money and letting it sit there. There are other formulas that we don't discuss in this class for situations where you're adding money to the account over time. That's going to look different. But this is just depositing some money, letting it sit there for t years. R is the annual interest rate. We need to convert it to a decimal. So when banks advertise interest rates, they always advertise it as a percent. So we need to change that to a decimal to plug it in for R here. P is what we call the principal. That's the original amount that you deposited or invested in the account. And then plugging all of that into the right side is going to give us A, which is just the account balance after the T years. Now, the amount in your account after 2 years is going to look different depending on how the interest is compounded, or rather how often it's compounded. So there are going to be situations where we're told that the interest is compounded a certain number of times per year. So maybe twice per year. Let's use that as an example. So twice a year, they look at your account balance right now, they calculate the interest, and they put it in your account. And then 6 months later, they do it again, so twice per year. Or maybe it's 4 times per year, or maybe it's monthly, 12 times per year. Sometimes it's just continuously compounded, which is weird to think about, but the concept is that it's just continuously earning interest. And so if that's the case, if it's being compounded continuously, then we use this formula here, which doesn't have n. So that's kind of your clue as to which formula you should use. If it doesn't tell you how many times per year, you don't have anything to plug in for n, so using the first formula doesn't make sense. But we'll still have all the other information we can plug in, and then our base is e for that exponential function. So we're going to practice using those formulas here. We're going to write an equation for the account balance after t years, where $9,000 is invested at an annual interest rate of 2.5%. So if we go through and start identifying information here, the 9,000 is the principal. That's the amount that is invested. This is our rate. We need to change it to a decimal to plug in the formula. So we're just going to move the decimal point 1, 2 places to the left, and it's going to be 0.025. And so then using that first formula, I'm just going to copy them here so that we have them to reference. We're going to do this for different types of compounding. So the first one is annually. So remember in that first formula, n is how many times per year it's compounded. So if it's compounded annually, that's once per year. So n is going to be 1 for this first one. So we're going to have A equals, P was 9,000 times 1 plus R was 0.025. N is 1. And then the exponent is 1 times t, so it's just an exponent of t there. All right, for the next one, it says it's compounded quarterly. Quarterly means 4 times per year. So this is going to be the same, except n is 4. same value of P, same value of R, but N is 4. And that value of N shows up twice. So it's the denominator underneath the rate, and then in the exponent it's N times T. All right, compounded daily. We're going to use 365 for the number of days in a year. So these three are all the same, it's just we have a different value of N for each one. And then the last one says compounded continuously. So we don't have a value of N there. And we're just going to substitute into the second formula. So P is still 9,000. Then we have a base of E. And then our exponent is R times T. One thing to note here, in case you're, different people are going to plug this into the calculator differently once we go to plug in a number for t. The exponent on each of these only applies to the base. So let's look at the simplest one here at the end. The exponent only applies to the base of e. So it's e to that exponent, and then we take it times 9,000. The exponent is not on the 9,000 as well. If it was, then the 9,000 e would be in parentheses, but that's not the case here. Similarly for these, the stuff in parentheses is your base. You could, calculate that out. So the base here is 1.025 if we figure out what's in the parentheses there. So it's 1.025 raised to the t and then times 9,000. Again, the exponent, the 9,000 is not being raised to the exponent there. If you plug a number in for t and you have a scientific or graphing calculator, you should be able to just type in everything as is, as long as you put the parentheses in the right place. And you might have to put parentheses around your 365 times whatever t is, depending on your calculator. But if you get all your parentheses in the right place, it should do the order of operations for you. So on that note, we want to know here after 10 years which account has the most money. So I'm going to do that off to the side here. So 10 years, that's the value of t, right? So we're just plugging in 10 for t here. And so like I said, you can plug in 9,000 times 1.025 to the 10th, and your calculator, if you have a scientific or graphing calculator, it should know order of operations, and it'll know to do the exponent first and then the multiplication. So I'd encourage you to pause the video and try that, because this compound interest formulas aren't super difficult, but most of the time if you get a wrong answer, it's more of an issue of typing it in your calculator. So make sure you get comfortable with your calculator and how it works. And so I would encourage you to pause the video and see if you get this number here. We're going to do the same thing for each of the rest of them. We're going to plug in 10 for t. If it helps you to figure out what that number is in parentheses first, that's fine. I would not recommend rounding it though. When we get to this denominator of 365, it's going to be a crazy decimal. So I would just leave it in your calculator and then do the rest of the arithmetic if you want. And like I said, some of you are going to need parentheses around the 4 times 10, or you can just do 4 times 10 and just type in the exponent as 40. That might be a bit simpler. You should get $11,547.24 for that one. Again, you can figure out 365 times 10 first, or you might need parentheses around that. And then for the last one, it's just 9,000. 9,000 times e to the 0.025 times 10. And so if you have a scientific or graphing calculator, you should have an E button. E is an irrational number. So it's kind of like pi or square root of 5, where it's just going to be a really long, never-ending, non-repeating decimal. And so your calculator should have an E button that you can use for this one. And so we can see that as the interest is compounded more often, you end up with more money at the end of the 10 years. So compounding 4 times per year already gave us more interest than once per year. 365 times a year gives us more than that, and continuously is always going to give us the most.